Thank you. All right, we're going to be talking about arithmetic and geometric sequences today. So last week, on Friday, we talked about the golden ratio, right? That's actually the golden sequence where we drew that spiral, right?
Right.
So we're going to be talking about some more sequences today. These are very specific. They're called arithmetic and geometric sequences. So we can easily find the pattern to find the next term if it's arithmetic or geometric. So let's start with the first example, problem 1a. It says extending sequences. So what we want to do is I want to find the next two terms in the sequence. I know you guys already have the answers there in your notes. All of your answers are already there in your notes. But I'm going to talk about how they got from each step. Okay? So the first sequence we're given is 5, 8, 11, 14. So we have to ask ourselves, what happened from 5 to 8? Plus 3, right?
Yeah.
And then, well, that's pretty straightforward. Yes? Well, we have to make sure that that's the sequence, that's the pattern happening from each term to term. You ready? So from 8 to 11, is it the same thing? Plus 3? There we go. Oh, oops, it jumped. And then 11 to 14, well, that makes sense. It's plus 3, right? So we're adding 3 to get the next term. So if I add 3 from 14, to 14, what would be my next term? 17. And then I can do it again, right? 20. Beautiful. Very nice. All right, let's take a look at problem 1b. It says describe this pattern. So I've got 2.5, 5, 10, 20. Times 2? Because if I multiply 2 to 2.5, we get 5. And if I multiply 2 to 5, I get 10. If I multiply 2 to 10, I get 20. So to get the next term, we're going to multiply by 2, and I get 40. Multiply by 2 again, we get 80. Not too bad, right? So far, we've either added or multiplied to get the next term, right? So those are both called something special. So in problem 2, it says identify an arithmetic sequence. Arithmetic sequences, you're going to add. There's a common difference. So I want you to write that down next to problem 2. You're going to add. Arithmetic, you always add. So write that down next to problem 2. That's what the notes I want you to add. Arithmetic means we're going to add. All right. So the directions here say tell whether the sequence is arithmetic. If it is, what is the common difference? So what I mean by common difference is I want to know, well, if I subtracted the second term and the first term, so if I take the first term from the second term from the third term from the fourth term, etc., 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 do we get the same difference? So here, if I say 3 from 8, or I could ask myself, 3 plus what gives me 8? It'd be 5. We have a positive 5, right? And then 8 plus what gives me 13? Question? All right. 13 plus what gives me 18? 5. Beautiful. So my common difference here, my common difference is 5. My common difference is 5. And I added in here because I want to see, can we get those next two terms? And that is not in your notes. So here, 18 plus 5 is going to give us 23. And then 23 and 5 is going to give us 28. So we can find the next terms in the sequence, right? And notice I have that dot, dot, dot there at the end. What's that mean? It means it keeps on going with that pattern. Beautiful. Very nice. All right. Let's try problem 2b. 2b says, tell whether the sequence is arithmetic. If it is, what is the common difference? So here, 6 to 9, what do I add? 3. 9 to 13, what do I add? 4. Oh.
There's a problem there.
Problem there, right? Why? What's wrong?
How do you know from 3 to 4?
It's not the same difference, is it?
No.
So is it arithmetic?
No.
No. Well, and I found that other one is 4 also. So no, the sequence does not have a common difference, so it is not arithmetic.
So then what do we put?
We can't find the next terms, that's it.
So it's over.
So it's over.
All right.
I know, right? Very sad. There might be some other pattern, but it's not arithmetic. All right. Next, you ready?
Yeah.
This one I think is a little trickier. Geometric is a little trickier. You ready? So it says we're identifying geometric sequences. Tell whether the sequence is geometric. If it is, we're going to write the common ratio. So for a geometric sequence, you're going to multiply by something. So write that down next to problem number 3, example 3. Geometric sequences, you're going to multiply by something. Yes. I don't. Sorry. All right. So I'm going to look to see what can I multiply 20 by to get 200? By 10. What if I didn't remember that? What if that wasn't a rule I remembered? What could I do to find out what we're going to multiply? Divide, I would say 200. I was going to say 2000. No. 200 divided by 20 is 10. 2,000 divided by 200 is 10 times 10. 200,000 divided by 2,000 is 10. Ah! Oops, I pushed the button twice. That's okay. So my sequence has a common ratio. My common ratio is 10. All right. So could I find the next two terms? We can multiply by 10, right? So 200,000 times 10 is
10. Oh.
Oh, I missed 20,000, didn't I? Oops. I can fix it. We're going to fix it. So this should be 20,000. 200,000. Easy to fix. And then times 10 would be 2 million. Oops. Easy to fix, right?
Yeah.
I apologize. All right, y'all ready to try another one? All right, the next one, pull my screen back down. It says tell whether the sequence is geometric. If it is, what is the common ratio? So we're going to look to see from 2 to 4, it's times 2, right? And I can divide. 4 divided by 2 is 2. There we go. So we're multiplying by 2. From 4 to 6, we're going to multiply. Remember, because I'm asking, is it geometric? So I know I'm going to multiply, right?
Times 1.5.
Times 1.5. I could divide 6 divided by 4 and get 1.5. Right?
Yeah.
Here, 6 times what gives me 8? So I'm going to divide. 8 divided by 6 is 1.3 repeating, right? Here, 8 times what gives me 10? If I divide, 10 divided by 8 is 1.25. So do I have the same ratio here?
No.
No. So is this geometric?
No.
No, it is not. So the sequence does not have a common ratio, so it is not geometric. All right? Sir? Let me know if you change your mind. All right. Last example. I like this one. It says tell whether the sequence is geometric. If it is, what is the common ratio? So here I have 5, negative 5, 5, negative 5, 5. Well, I see the pattern, but I want to know, is it geometric?
No.
Well, let's see.
Yes, it is.
5 times what gives me negative 5? Negative 1, right?
Oh, it is.
Negative 5 times what gives me positive 5? Negative 1. 5 times what gives me negative 5? Negative 1. Negative 5 times what gives me positive 5? Negative 1. So it is geometric. What's my common ratio? Negative 1. What? Not 10. That should say negative 1. Oops. This is what happens when I copy and paste. I did copy and paste. All right. So now, if you'll turn your paper over, there are 14 questions. So the first 6 I ask for the next 2 terms. Right?
Yes.
And I want to know how you got there. Did you add? Did you multiply? Did you subtract? Did you divide? And by how many? Okay? Yes, sir.
Yeah, he has a lot of pus.
Wait just a second. I can wait. The next section asks, is the sequence arithmetic? What does it need to do to be arithmetic? Add or subtract, right? So are you adding or subtracting by the same thing? And then I want to know what is the common difference. So you're going to write D equals and what that common difference is. Okay? If it's not, can you give me a common difference? No. So what are you going to say? Not arithmetic. Right?
Yeah.
The last 4 problems ask, is the sequence geometric? So what are you going to do to tell whether a sequence is geometric? Multiply or divide, right? Multiply or divide. And I want to know what is that common ratio if it is geometric. All right. When you're done, come check your answers with my key. All right. Will you push the stop button, please?